So this is Taylor. Taylor is a little girl that's really into music and also into birds. In school, she's one of the hip and cool kids, at least since Taylor 3.0. But at the same time, she's very strict and has a very complex mind. She can run very fast, but sometimes she's also quite slow and no one really knows why. Like most little kids, Taylor has several big dreams, and her biggest one, she always wanted to have a pet. But not like this one, she always wanted to have a dinosaur. So one summer, Taylor made a school trip to Russia. And when she came back, she was super excited to tell her parents about all the amazing things that she had done and seen in Russia. So the first thing that she did, she ran back to her house, and there he was. Dino. He was just like she always imagined him to be. He was a little old, but that's okay. It just made him more mature. And at the same time, he was still super fast and dynamic. He had this weird sign on his body, but she liked it. It made him unique. So the two of them, Taylor and Dino, were very happy together. But soon Taylor found out that having a pet is actually a lot of work. And especially communication is hard. They seem to speak a different language. Taylor, on the one hand, is very strict, while Dino doesn't seem to care that much. And he has this weird thing where sometimes he mistakes Taylor and everyone else for a duck. He seems to go by the rule, if you walk like a duck and quack like a duck, you must be a duck. So the two of them realize that they have a problem and they need to find a solution. They need to figure out how to better work together. So good morning. My name is Matthias Tretter. It's me again. Because Graham Lee unfortunately couldn't make it, so it's me with a second talk. I hope you're all well. I hope none of you is too tired. Thanks for coming up early. It's always a little hard to come to the first session on the second day of a conference, so thanks for being here. A while ago, I asked on Twitter which image comes to your mind when you think about Swift and Objective-C, and apparently people have feelings about this. I got a couple of answers, like this one from Megan. This is how she would describe the experience of working with Swift and Objective-C in one code base. But back to my talk. Back at WWDC, when Swift got announced, we were all super excited, right? Objective-C without the C. Now we know that Swift is everything but Objective-C without the C. It was just a marketing slogan. And to be honest, Swift 1.0 was quite rough, right? Like at MindNote, we didn't really use it for anything. We were just toying around a little bit with it. With Swift 2.0, things started to get a little better. We started to write our unit tests in Swift. We started to write our watch app in Swift. But with Swift 3.0, Swift suddenly felt ready for production. And we started to integrate Swift into our main code base. And nowadays, with Swift 4.2, we're at over 50% Swift code. So since a while, we at MindNote go by the rule that new code gets written in Swift, unless there's a specific reason not to, which sometimes might be the case. So why would you end up with a mixed code base, or why would you want to have a mixed code base in the first place? Maybe you're in a similar situation than we are. Maybe you're working on a quite big app that was written years ago, and you have a lot of code written in Objective-C that obviously you don't want to throw away. And at some point, you decide that you want to bring in Swift into the mix, and you want to write code in Swift. Then you end up with a mixed code base. Or you have legacy code that was third-party code that was written in one language or the other that you need to use. Or there might be other reasons, like performance, for example. Sometimes you might be faster when using Objective-C, or you might even want to drop down to C or C++. And some things just work better in one language or the other, like reflection, for example, or NSProxy, which you can't even use in Swift. But reflection is kind of baked into the DNA of Objective-C with being a very dynamic language. So I love Swift, but I also love Objective-C. And sometimes I get a little kind of sad even when I see that our community seems to be divided. There's like the Swift camp that hates on Objective-C for being old and having these weird @ everywhere and being unsafe. And then there's the Objective-C camp that hates on Swift for being overly strict and complex and everything. I think we have two great languages at our disposal, and we should use both, and we should use them according to their strength. So this is actually what this talk is about. So how to use both languages to your advantage in one app. So what if Dino wants to talk to Taylor? In general, this works very well because Taylor usually understands everything this Dino has to say. There's just some things that sound a little bit weird to her, but it's quite easy to improve those. So if we want to use existing Objective-C code in Swift, there's not a lot that we have to do to make it work. It usually works out of the box. And there's a tool called Clang Importer that does the heavy lifting for us, which translates existing Objective-C constructs into Swift constructs. And we all know that the naming guidelines are quite different between the two languages, with Objective-C being very verbose and Swift trying to be shorter and focusing on clarity. So Clang Importer usually does an automatic translation and gets a lot of things quite right, from translating from Objective-C, existing Objective-C code, into Swift code. But still, since it's an automatic translation, of course it can't get everything right, so there might be situations where we want to fine-tune it and where we want to improve the translation. So if we want others to understand us, we need to convey a clear intention. And this, for example, can be done by making things more explicit. I'm personally a huge fan of making things explicit, of making implicit assumptions explicit. And I feel like this is actually one of the great side effects of Swift on Objective-C, because it has brought more clarity to Objective-C. Objective-C is a quite old language, was founded in the 1980s, or created in the 1980s, but it has gained more and more features and annotations over the last couple of years, and many of them were clearly influenced by Swift or to improve the interoperability with Swift. Like, for example, we got properties, class properties, designated initializers, instance type, NS-enum, NS-options, nullability, lightweight generics. These are all things that Objective-C has gained over the last couple of years, and they are there to enhance the interoperability with Swift. But at the same time, they add a ton of value to Objective-C only code. So even if you're not even touching Swift and writing in Objective-C only, using these features, using these annotations, adds value to your code because you make things more clear and it gets easier to reason about your code. Because suddenly we don't have to assume anymore what's in an NS array. It's right there in between angle brackets. You can see it, and the compiler warns you if you put something else in. We don't need to assume anymore whether a variable can be or can become nil. It's right there with nullability annotations. So on top of these annotations, there are many more that are solely there to enhance the interoperability between Objective-C and Swift, and they influence how existing Objective-C code gets imported into Swift. Like NS-Swift name, Swift unavailable, typed enums, refined for Swift, NS-Swift no-throw, typed extensible enums. These are all attributes that we can use to annotate existing Objective-C classes, methods, types, etc., to behave more like first-class Swift citizens. Like, for example, in Objective-C, we often have a bunch of string constants that represents possible values, and as attributed string keys, for example. And if we annotate this type with NS-typed enum, what it does, it actually gets turned into an enum-like struct in Swift. So suddenly we gain type safety in Swift for a feature that was written in Objective-C, which is great. And then there's a third category of things that we can do. As developers, I would say we are often lazy. And I think that's a good thing, because we want to make our lives easier. We want to find solutions to problems. And there's crazy things that we can do to make working with code more convenient for us. And one example is macros. So if you want to start a discussion at your company, you might want to sneak in this little code snippet in one of your next pull requests. var and let for Objective-C. So that's the Objective-C way of doing type inference with underscore underscore auto type, and it's highly controversial. I'm sure there are people in there that hate me for making this slide or looking or watching the video that hate me when I talk about this. And there are other people who love it, like myself. I love it because it makes, for me, it makes it easier to context switch between Swift and Objective-C while working in a mixed code base. Because we have the same construct now in Swift and Objective-C with var and let, and I don't have to think about it anymore. And at the same time, I feel like it encourages constness in Objective-C. Of course, we could always use const directly. It's a C keyword, but I haven't really seen const used in Objective-C out in the wild a lot. And I feel like it comes more natural with var and let because we're used to the same concept with Swift. So it has kind of changed the way how we write Objective-C code and MindNode, because now we default to constness and only switch to var if it's actually needed. There are many, many other things that you can do with macros, like you can build your own defer for Objective-C, for example, which is a pretty nice feature of Swift. And I encourage you all to check out the PSPDF Kit blog post for this, for especially, because they are doing crazy things with their framework. And fortunately, they are writing about all the things that they do and the lessons that they learn. So, for example, this blog post by Marcin here, he's actually, I'm not sure if he's in the room, but he's here at the conference as well. He gave a talk yesterday. So he wrote a very in-depth blog post about some of the nitty-gritty details that they found when they tried to make a first-class Swift API for their Objective-C framework. Okay, so now we've heard about some of the annotations, so let's take a look on how we can actually use them in code and how it changes how Objective-C code and Swift code interoperate. Where is my mouse? Here it is. Okay, so I had an app idea. I feel like it's going to be the next big thing, because we all have our favorite words, right? So I created an app that displays the best words, my favorite words, in a tree-like structure. So that's just a function to create this tree-like structure. And I have my favorite words in German, which are Fernweh, Fremdschämen, and Halskrause FX. My favorite words in English, which are Kindergarten, Doppelgänger, and Lederhosen, mostly because they are actually German words and not English words. And my favorite words in Russian are da, niet, and vodka. Because as you might be able to tell, I can't speak any Russian, so I just chose very simple words. Okay, so let's take a look at the app and how it looks like. Let's run it. And it crashes. So what happened? Let's take a look. It's here in the main file. So conveniently enough, someone, me, already named that variable crashing word. So this is why it crashes. But if you take a look, we create a node instance here without a title and without a language. And we want every node to have a title and a language specified. So we would actually want to prevent this. We don't want this to be able to be possible at all. So if we take a look at the node class, which was written in Objective-C, we can see it's a class that inherits from an NS object with title and a language property, parent node and child nodes to make up for the tree structure, getter to go to the root node, and then we have this initializer init with title and language. But since it's an NS object subclass, it also inherits the initializer init without any parameters from NS object. So what we can do is we can use the annotation NS Swift name. Wait, that's the wrong line. There you go. We can use the annotation NS designated initializer to mark this initializer as our designated initializer. And then we can also mark init as unavailable. So if we now try to build that app again, we get a compile error. I hope everyone can see it. But it says init has been explicitly marked unavailable here. Init is unavailable. So the compiler doesn't allow us to create this word anymore, and we can safely remove it. So let's take a look at this node class again. So that's the Objective-C interface, and we can take a look at the generated interface to see how this class looks to Swift. So we have an open class node, subclass of NSObject, and then we can already see that there is some problems. There are like a lot of exclamation marks basically everywhere. So we are dealing with implicitly unwrapped optionals here, everywhere, and that's not what we want in Swift. We want optionals or non-optionals, depending on whether a variable can be nil or not. So let's fix this. We can use NSAssume non-null begin and NSAssume non-null end, which basically marks everything in between as non-null. And now we only need to annotate the variables that actually can be nil, like the parent node, because the tree structure has to end at some point. And also these two parameters are nullable. So if we take a look again at the generated interface and how it looks to Swift now, we can see that all those exclamation marks are gone. We are having non-optionals here for the title and the language, optional for the parent node, and so forth. So it looks way better. But there are other things that we notice here that don't look quite right yet. We have this language property here, which is of type string, which is a little weird because in our app we only want to support certain languages and we don't want the language to be able to hold any string at all. So only the languages we support. So if we take a look at language.h, we can see that language is just a type def for NSString. So of course it gets imported into Swift as string. And we have some variables defined here, English, German, and Russian. These are the languages that we want to support. So if we take a look at the Swift interface of this file, it looks pretty similar. We have a type alias, and then we have this public let constants. But what we can do is now we can use NS-typed extensible enum. And what it does is now this language type gets turned into a struct in Swift. So if we look at the generated interface again, now we have a struct language, and the three languages, English, German, and Russian. And if we now take a look at the nodes generated interface, we can see that the language property now is of type language and not string anymore. So we've gained type safety for the language here. And if we try to build this, we're going to get some errors, which says language English has been renamed to language.english. We can fix this, or we can make Xcode fix all these issues. And then we can even replace language dot with just a dot and use type inference. Oh, somehow not all issues get fixed for whatever reason. Let's go back. Okay, Xcode just randomly replaces some of the instances and doesn't replace others. Refactoring, yay. Okay, it built again. Perfect. So let's take one more look at the generated interface of our node class to see whether there are other things that we can improve. Like, for example, this child nodes array. It's an array of type any, but we actually know that all our child nodes are of type node. So we can fix this and improve it. And then down at the bottom here we have this function getLevel, which has two parameters of type unsafe mutable pointer of int, which isn't very swifty, so we can also find a way to fix this. So to make our array, to change it from type any to type node, we can use lightweight generics in Objective-C and put the type in between angle brackets. And now if we build this again, we already get a warning that this forecast that we've been using here when we iterate over all the children isn't needed anymore, because our node, our child, is now known to be a node. So that's great. And then let's take a look at this function getNodeLevel, which takes a pointer to an NS integer, or two pointers to an NS integer, and ends up in a very non-Swift interface. So we can use NSRefined for Swift, and what this annotation does, it imports this function as a private function. So it imports it as a function with two underscores in front. And then we can use an extension on Node to provide a more Swift-like API. So we have this extension on Node here. For example, a more Swift-like API would be to use a tuple that returns the node level and the sibling index. And since this function gets imported as a private function with two underscores, we can actually use it in this implementation, so we don't have to repeat that code, but we can still provide a nicer API to the outside. So now Swift, like all our Swift clients, can use this tuple instead of having to deal with this method that takes unsafe pointers. Okay, one more thing. So if we take a look at what this app actually does, it creates these words, and then it prints the recursive description of our root node. But I actually called this root node and not root. So what happened? Why is it called root? If you take a look at node, you can see it's called root node here. But Clang importer, since it's of type node, and Swift usually tries to avoid duplicated phrases, so it simply tries to be clever and removes this node from here and imports it at root. But I would still prefer to call it root node, because for me it's clearer that way. So we can use any Swift name to override that name, how it gets imported into Swift, and now it's still called root node in Swift. And if we finally run our app, we can see the best words being printed in German, English, and Russian. So that's a little demo on how we can use these annotations to actually improve our code, or improve how Objective-C code and Swift code work together. So what about the other way around? What if Taylor wants to talk to Dino? It's a little harder this way, because Dino doesn't understand everything that Taylor has to say. And Taylor often has to find simpler words that Dino can understand. So if we want to use Swift code in Objective-C and call it from Objective-C, there are certain limitations to this. It all starts with @Objective-C. That's the annotation that we can use to mark a type, a function, a protocol, etc., as being available in Objective-C. So this has changed with Swift 3. Earlier there were different rules where, for example, NSObject subclasses got imported into Swift automatically, but fortunately this has changed, so now we have to mark everything explicitly that we want to import in Objective-C. And same as with NSWift name, we can override the name, how it gets imported into Objective-C. So if the automatic translation doesn't really fit our needs, we can give it a new name. There's just one caveat. Refactoring is already bad enough in Xcode, but if you use something like this, you'd have to take care of the refactoring yourself if you rename it at a later point. But what about my tuples, my enums, my structs? I love them so much in Swift. Can I use them in Objective-C? Well, there's a short and a longer answer to this question. The short answer is no. Okay, now that we got that cleared, let's take a look at the little longer answer. So tuple struct enums with associated values or enums that have a different type than int are not supported in Objective-C, so we can't use them directly. But there are, of course, workarounds that we can use to work around this issue. Let's take a look at an example. So assume we have a class that's written in Swift, and we want to use it from both Swift and from Objective-C. So that's a simplified example from MindNode. We have a node dragging state. If we want to use that class in Objective-C, it has to be a subclass of NSObject. That's one of the rules. And it has to be marked with @Objective-C. But let's break it down. There's an inner type, an enum mode with two cases, a dragging case and a node creation case. And both cases have associated values. So this enum is not available in Objective-C. And then we have this designated initializer that takes the mode and the location and sets up the whole dragging state. But since it takes that mode as a parameter, it's also not available in Objective-C. So suddenly we can't instantiate this class in Objective-C because mode is not available there. But what we can do is we can add convenience initializers and mark them with @Objective-C. And these convenience initializers only use types that are available and visible to Objective-C. So they simply take the node IDs directly or the view model, internally create that enum, and forward it to our designated initializer. So that's great. Now we can use this or instantiate this class from Objective-C as well. But at the same time, it somehow clutters our API, right? Because instead of just having one initializer, suddenly we end up with having 3 initializers. And we don't actually need these 2 in Swift. So if you're like me, this kind of thing bothers you, because maybe at some point in the future, you will remove Objective-C, and then you end up with code that you actually don't need anymore. And I don't like that. So what we can do is we can add another annotation. We can mark this as not available or as obsolete in Swift with @available Swift obsoleted 1.0. So as weird as it looks like, this actually works. Now these methods are available in Objective-C because they are marked with @Objective-C, but not available in Swift because they're obsolete there. And yeah, this works. There's an even longer answer to this question, what about my structs and enums? But now we're entering a whole different zone. There's a protocol called Objective-C Bridgeable, which allows us to bridge Swift types, Swift value types, to Objective-C. And this is actually what's used internally to bridge the shiny new Swift 3 value type. Well, they're not that new anymore, but still to bridge the Swift value types like URL to NSURL, like index path to NS index path data, NS data, and so forth. So we can also use this in our code, but there's this pesky little underscore in front. So it's a private protocol. We're not really supposed to use this, so you didn't hear about it from me. There was a proposal for an official protocol without the underscore, but unfortunately it got postponed, so we are left dealing with either using the private protocol or finding other workarounds like I showed you earlier. So optionals are great, right? Because they add clarity to our code. We don't have to reason about whether a variable can be nil or not. We can see it right there in the declaration. But non-optional parameters actually come with a little caveat in a mixed code base. Because if you're dealing with Swift-only code, you're fine. The compiler enforces that you can't pass in nil to a non-optional parameter. But if you're dealing with a mixed code base, you can actually call that method with nil from Objective-C. And depending on the mood of the compiler, you might get a warning or not, saying null pass to callee that requires a non-null argument. Sometimes it catches it, sometimes it's not possible to catch it. And if you then run that code, it simply crashes with an exception bad access. And if you look at the stack trace, somewhere you'll find something like own2 guaranteed and exploded, because Swift thought there's going to be a value there, but actually we passed in nil. So of course the right way to fix this is to fix the call side and not pass in nil. But sometimes that's not so easily possible, or it might not even be possible at all if you're programming a framework and you want to make sure that it can't be used wrongly so that it doesn't crash if your users use your method. So we have to find a way to fix this as well. But it's a non-optional. We can't check for nil in Swift. The compiler doesn't allow a check whether it's nil or not. But of course, when there's a problem, there's a workaround. So you can, for example, do something like this. That's what we do in MindNode, little assert not nil function. And it's very simple. Basically, it all boils down to this. So we simply cast the type, the variable to an optional type, and then you can check whether it's nil or not, and handle that case according to your specification or how you want to handle it, and handle it more gracefully than crashing. So at the end of last year, we shipped MindNode 5, which was our biggest update so far. And we were busy working on fixing the last bugs, adding the last few little features. But a couple of days before we wanted to ship, we noticed something pretty bad. We were leaking memory. But we were not leaking just any memory. We were basically leaking all of it. Like nothing ever got destroyed. That's a disaster, right? You can't ship an app that doesn't leak any memory. So we had to fix this. And of course, we used instruments. We used the memory graph debugger. We saw the leaks, but we didn't understand them. We couldn't figure out why this code was actually leaking, why there was a memory leak. So after a while of debugging where we couldn't find out anything, Thomas, a coworker of mine, used git bisect, and he could actually identify that the commit that introduced this leak. And sure enough, it was a commit by me. So what I did in this commit, we had a class in Objective-C that did a little bit too much. So I refactored it and pulled out some code out of it, and along the way, as we usually do it, I converted this Objective-C code to Swift. So, okay, now we knew it's this commit, but still we couldn't figure out what was wrong. Everything kind of looked correct, and like 4 developers were staring at this code for hours, and it's like, we don't know what's going on. So Thomas had an hypothesis. Maybe there's a bug in Swift. So we rewrote that class that I pulled out in Swift in Objective-C again, and the leaks were gone. So that was great. We could ship our update. We were happy. But still, there was this like, why did this happen kind of thing. And after we shipped our update, we had a little bit more time after a while, after the first problems were fixed. And then, of course, we filed a radar, we filed a Swift bug. And I'm sure every one of you has opinions about radar. Like I personally was skeptical. I didn't really have a good experience with radar in the past. So I didn't think that we would get anything out of it. But fortunately, things have changed. So pretty quickly, actually, Joe Groff jumped onto our bug. And he identified a minimal case to reproduce that memory leak. So the problem was if you have an NSObject subclass and a variable of type anyHashable, and you cast that variable back to its original type, you leak. So it leaks at the print statement here at the cast. NSObject subclass, declare this variable of type anyHashable, cast it back to custom entry, and it leaks. So we filed that Swift bug on November 23rd at the end of last year. And it got fixed on November 28th. So it literally took them 5 days to not only identify the problem, but actually fix it in Swift upstream. So that's great. We personally still ship our Objective-C implementation of that class, but that's a different story. So looking back, Dino and Taylor figured out ways on how they can improve their communication, how they can work better together. And there's a lot of things that they can do to make their intentions clearer, to make the other one understand them better. We have 2 great languages at our disposal with Objective-C on the one hand and Swift on the other hand. So let's embrace a world where we use both languages, where we use them according to their strengths. Let's be multilingual and tame our mixed code bases. Thank you.
Matthias, thank you for your talk. It's really hands-on knowledge. Thanks. Maybe we'll have questions from our audience. Если есть вопросы, задавайте. Будем пробовать переводить. Если можете, задавайте на английском. Давай.
Так, ну я по-русски, наверное, спрошу. Какое будущее ты видишь для для какого-то сложного кода, который работает, например, с кучей бинарных данных, может быть, Bluetooth или сокет или еще что-то такое в Swift, потому что сейчас с этим работать неудобно.
It's a question about future for some complicated codes, for example, binary dates, Bluetooth, or something, because right now we have right now it's inconvenient.
I'm afraid I can't fully follow the question. Can someone else help and jump in?
Do you believe that Swift will be more convenient for complex code that works with a lot of data, raw data in memory, like yes, low-level, unsafe working with data?
Okay, you're asking about whether it's going to be more convenient to work with unsafe, because like by design Swift tries to be a safe language.
Yeah.
So it's by design that working with unsafe types, having all this, it's actually including unsafe in the name of the type is by design because they want to make sure that you know what you're doing.
It's also called the universal multi-purpose language by design, but working with raw data is very, very inconvenient.
Yeah, I'm not part of the design committee of the Swift language, so I can only tell you what's my opinion about it.
Yeah.
But yeah, just as I mentioned, I feel like this is on purpose and it has its reasons and it can still be used for doing this kind of code. It's just not really encouraged, I guess, to like work in an unsafe way. That's why, but it's still possible and it's like not too hard.
So let's imagine if you will develop some kind of maybe audio codec in 10 years in future. Would you use C language or Swift?
That's a very hypothetical question.
Yeah.
I'm afraid I'm probably not the right person to ask because I've never worked on something as low level as an audio codec. So I'm not really sure what it takes to implement an audio codec, and I would probably first need to like make myself familiar. What are the challenges? What is the kind of code that I need to write? And then based on this, I would decide which language I choose. So I always try to choose a language that suits the problem I'm working with. So there might be better languages then for this kind of problem. For us, we're working like on an app level, where Swift is kind of very good choice.
But do you think that Swift should move into this direction as well?
I mean, if it can still maintain its advantages in other fields and can still maintain being a safe language, then why not? But it's always like having trade-offs, I guess.
Hello. And how do you mix old Objective-C code without annotations, without defines, and new Objective-C code with a lot of this new stuff?
Yeah.
And how do you mix it in one application? Because do you migrate some way or anything else?
Yeah, so you can use code without annotations as the example has showed in the beginning, and then you can add annotations gradually over time if you feel like. And that's exactly what we are doing. Like whenever we come over an old class that was written in Objective-C, which doesn't have any annotations yet, and we need to use it from Swift, like we try to add annotations, make it more clear, clean stuff up, extract stuff out. Like we're following this Boy Scout rule, basically. Whenever you touch a file, leave it cleaner than you found it. And I feel like that's a very good rule to follow, like because you don't need to annotate all your code at once, which can take weeks probably if it's a big code base. But you're starting to annotate the code that you're actually working with right now at the moment and make it cleaner, add more annotations, make it safer along the way.
Hi, thanks for your talk. We started rewriting our Objective-C app to Swift, and now we have mixed code base, and our build time increased by on 50%, I think. Do you have any tips for decreasing build time?
Yeah.
Thanks.
If anyone has any tips, please let me know. We have the same the same problem. I guess like one thing that like it got a little better from our measurements with Xcode 10, and there's also a WWDC talk about improving compile performance where they go over several things. Didn't help for you? Okay. Yeah. Modularization.
Because it has to figure out every possible way you could use plus. It thinks, well, maybe it's integer, maybe it's a string, maybe it's an array, and it explodes. So every time somebody comes to me and tells me their build times are very slow, I look for plus and take it out.
Okay. Thanks, Rob. That's a good point, and like pretty similar to this, type inference can also be a big problem for build times. So using explicit type instead of type inference, especially for like complex statements, can help speed up your build time as well. There's I don't know by heart, but there's a flag that you can pass in where it actually shows the time that it needs to compile for each function. And if you like pass that flag in, you can see and maybe identify some functions that take a long time to build, and then you can go from there and see, okay, maybe you're gonna add some more types there, maybe gonna remove some pluses or whatever, make the code harder to read but faster to compile. Yeah. And then another tip is you can use modularization like frameworks. If you can split your code up into frameworks, because then you don't have to build everything at once, and only like the part that you're currently working on, so that helps as well.
Еще вопросы? Давайте последний вопрос, и Матиас выберет лучший вопрос.
Hi, I try to ask, am I right that any new feature that you build, you prefer write in Swift?
That's what we default to, yes. But like as I mentioned, not everything new gets written in Swift. There might be reasons why we choose to still use Objective-C or even C++ at some parts, but most of the new code gets written in Swift. Like that's our default choice if there's no reason not to write it in Swift.
And which percent of your code base already written in Swift?
Right now it's over 50%. I think it's like 53, 54 or something. And we started with Swift 3, yeah.
Looks great, thanks.
Так, все, мы тогда закончили с вопросами. Matthias, you need to choose best question.
Okay. I'll choose the compile time question because I feel like it's a problem everyone faces if you're working with a.
Да, у нас еще рядом с залами будет работать дискуссионная зона. Я очень прошу вас подходить к зарубежным спикерам, находить ребят, которые говорят по-английски, задавать через них вопросы, потому что наши зарубежные друзья очень скучают, когда им задают вопросы. Matthias, we have a discussion zone. Please. Что? Все, да? Thank you for your talk.
Yeah, thank you.